हेलो बच्चों, देखिए इस प्रॉब्लम में एक लोड है जिसका वेट W है एंड इट इज़ बीइंग रेज्ड बाय यूजिंग अ रोप थ्रू अ हाइट h. Now the greatest tension which the rope can safely bear is NW. That is, the maximum tension in the rope can be NW. Okay, and the weight of this block will be acting downward. We need to find the least time in which the ascent can be made. So in this problem you have to keep in mind that block is initially at rest and it must again stop after moving h in upward direction. So in this problem you have to think about what is the maximum acceleration which we can provide to the block, because greater the acceleration, time will be minimum. And you also keep in mind that we have to stop this block also. So first, after accelerating this block, you have to retard it. So you must have done a question in kinematics where a body, a train, starts from rest and again comes to rest, and it is accelerating at the rate alpha and decelerating at the rate beta, and total time taken is t. So the displacement in such cases can be given by half alpha beta upon alpha plus beta into t square. So you have to apply all this concept and solve this problem. Now let us look at the solution. So this is the situation, and we have plotted v versus t graph, and the total time taken is, let's say, capital T. So the maximum acceleration which we can provide is NW is upward force and W is downward force. So net upward force is NW minus W divided by mass. Mass is W by G. So from here we can see that maximum acceleration which we can provide to the block is N minus 1G. Now we have to retard this block, but tension force is acting in upward direction, so it will not help in retardation of the block, but the downward force W will help in retardation. So the net downward force will be maximum when this T becomes 0. Okay, so now the block will retard with acceleration, with the retardation G, because only weight will be acting in the downward direction. So the maximum acceleration is alpha, which is n minus 1g, and maximum retardation is g. Okay, so putting the value of alpha and beta in this expression, and the displacement is h. Okay, so putting the values, we get h equal to half n minus 1g into g upon n minus 1g plus g. So now by simplifying this expression, you will get the minimum time, the least time which will be taken to raise this block to height h. Thank you.